Now that we've learned some ways of solving systems of equations, let's turn our attention to some applications that involve systems. This table shows the percent of students studying for a Master of Divinity degree for both women and men for the years 1993 up through 2005. The question we'd like to answer is, when will the percent be the same for both men and women? Now, to answer this question, we'll start by first finding a linear model for both women and one for men. And in the past, when we've found models, we've chosen 2 points, usually, and found the equation of the line that connects those 2 points. And this time, I'm going to use a regression line. Remember in a previous lesson, I went over how to find a regression line, and the regression line is a statistically generated equation that closely models a set of data. Now, it's fairly easy to find the regression line if you use your graphing calculator. Now, I'm going to let t represent the number of years after 1990. So, in this table, for 1993, that would be a t equal to 3, because that's 3 years after 1990. And then we'd have 6, and then 8, and then 10, and 12, and 15. And notice that I've entered these numbers into the graphing calculator under L1. So these are the time values right here. And then the percent for women I've entered into L2. And the percent for men I've entered into L3. Now I have 2 regression lines to find, because I have to find a regression line for women, and then I have to find another regression line that models the men's data. So first, I'd like to graph the data. So I'm going to go ahead and make a scatter plot. Now, to make the scatter plot of all this data, we're going to first of all have to press second and then stat plot, and we'll push enter on plot number 1. We'll make sure it's turned on and set to make a scatter plot of L1 and L2. Now that will be the women's data, because the women is in L2. And then we'll do second stat plot again. Let's go down to plot number 2 and hit enter on that. And we'll turn that on by hitting enter. And we'll make sure it's set to make a scatter plot. And this time we want it to be between L1 and L3, because the men is in L3. So we'll do second and then 3 to change that to a L3. And that should be all set. So we'll do zoom and then 9, because remember 9 is the zoom stat. And we see our data here. Now, once we get our scatter plot, we'll push stat, the stat key, okay, right here. And then we'll go over to calculate, and we'll go down to linear regression, AX plus B, and hit enter. Now, if we don't enter anything in here, it assumes that we're using L1 and L2 for our X's and our Y's. And so that'll work for the women's data. So we'll just hit enter, and we can see our equation. Now, we'll keep that in mind, because we'll write that down in just a minute. But now I'm going to repeat this process for the men. So to repeat it for the men, we're going to have to just go through everything again, hit stat, and then calculate, and then back down to linear regression, AX plus B, and hit enter. And now this time we have to specify L1, comma, so we do second 1 for L1, and then the comma button, which is right here, and then L2, which is second, and then 2. Or, I'm sorry, 3. L3. So we change that to an L3. And then once we hit enter, we'll get that equation. Okay, so remember, the default always is to count L1 and L2 for the X's and the Y's. And if we want anything different than that, then we have to actually enter those columns in with a comma separating them. So in the second case, we did L1, comma L3 to get the men's regression data. And that Now we have our two lines. So let's go ahead and write those answers down. Okay, so here are the two regression lines that we came up with. The first one is for the women, and notice I've notated that with a W to stand for women, so W of t, that's the functional notation. And the second equation is the one for men, so that's M of t. And they're both equal to y. And the idea is to solve this, we're going to use the substitution method. So since y equals this expression, and y also equals this expression, we can set the two right-hand sides of the equation equal to one another. So when we do that, we are going to get 0.859 t plus 22.6 equals negative 0.859 t plus 77.4. And we just need to solve this for t. So when we add 0.859 t to both sides of the equation, and then we subtract 22.6 from both sides of the equation, we'll end up with 1.718 t equals 54.8. Now I skipped a couple steps there, but hopefully you can follow along with that. I try to get my variables on one side and my numbers on the other. And then I'll divide both sides of the equation by 1.718, and that will give me t. So t comes out to be 31.9 years, and that's years after 1990. Okay, so years after 1990. And now as far as what the percentage would be, we can take that answer for t, 31.9, and substitute it in for t into either one of the two original equations. And when we do that, we get y equals 50. Okay, so, or very close to it. It probably needs to be rounded just a little, but we'll have y equals 0.859 times 31.9 plus 22.6. And when you put that into your calculator, it comes almost to exactly 50. Not quite because of round-off error, but it's really close to 50. And that's telling us that when they do finally become equal, they'll both be 50%. And if you think about it, that makes a lot of sense, because if 50% are women, then the other 50% would be men. So that does make sense. So we've got our solution. It happens at t equals 31.9 years after 1990. And of course, if we could equate that to a given year, so if we take 1990 and add 31.9, we'd get 2021.9. So it'd be during, almost at the end of the year 2021. And y is 50%. Now I don't know if you realize it, but what we just used to solve the system was the substitution method, because we had, this is our system of equations up here, and there's two variables, there's t and there's y, and notice in fact both of the equations are solved for y, meaning their y is by itself on one side of the equation. So think of this top equation as solved for y. So we took what was on the right hand side of the equation and substituted it in for y in the other equation. And in this case, that really just amounts to setting setting the right hand sides of the equation equal to one another. But technically we did use the substitution method. Now in this next example, we don't have a set of data given to us, but we do have enough information to be able to make linear equations. Now in 2008, the price of a 2007 Honda Accord was about $18,329, with a depreciation of about $22.56 per year. A student had $500 in 2008 and saved $1,700 each year, and assume he makes no interest. Predict when the student will be able to buy a 2007 Honda Accord for cash, and how much will the student have to pay? Now, there's a lot of information given there, and the key thing is to be able to break it apart and extract the information that we really need. Let's start by defining our variables. Let's let t be the number of years after 2008. Now, our first job is going to be to come up with two different linear equations, one that represents the price of that 2007 Honda and another one that represents the amount of money the student has saved. Now, I'm going to let H stand for Honda, so this first top equation is going to represent the price of that 2007 Honda. Now remember, the price started out at $18,329, but it depreciates about $22.56 per year. So we could say that the price of that Honda will be $18,329 minus $22.56 times t, where t is the number of years that have passed, because the price is going to go down by $2,256 each year. Now, as far as the second equation, S represents the savings that the student has made. Now, the student started with $500, so that's like the initial amount, and then he's going to save additional money, so we're going to add to the savings by $1,700 each year. So we'll multiply 1,700 times however many years pass. And again, this gives us a system of equations. We have two different equations, and there's two variables. The variables are really t and y. Okay, you can kind of pretend that these h of t and this s of t aren't even there. They're just really there to show you that one is representing the Honda price and the other is the savings. But think of it just as y equals one thing and y equals another. And since we're going to use the substitution method again, since y is equal to 18,329 minus 2256t, that means we can take that whole expression and plug it in for y in the second equation. Very simply, that just amounts to setting those two expressions equal to one another. So we will end up with the equation 18,329 minus 2256t equals 500 plus 1,700t. Now, I think you know how to solve this kind of equation. You want to get your variables on one side and your numbers on the other side. And so if we collect the variables over to the right side of the equation, so if we add 2256t to both sides and then subtract the 500 to get the numbers on the left, we end up with 17,829 equals 3956t. And then we can just solve for t by dividing both sides by 3956. And when we do that, t comes out to be 4.507. I'm going to write it up here because I'm out of room down there. So t equals 4.507. So that's the number of years it will take for the student to save enough money. Now that's part of the question. If you look at the question, it says predict when the student will be able to buy a 2007 Honda Accord for cash. So we've done that part. We're predicting that it would take about 4.5 years for that to happen. But the other part of the question says, how much will the student have to pay? Now, to answer that part, we would have to take this answer, 4.507, and substitute it into either one of the two given equations. I'll go ahead and use the bottom one. So y would be 500 plus 1700 times 4.507. And when we work that out, that comes out to equal 8162 roughly. And that would be the amount of money. And so that answers the other part of the question. Now I'd just like to show you how you can check this on a graphing calculator. And so you'd have to start by entering your two equations in. So for the top equation, we'll put in the price of the Honda. So 18,329 minus 2256T. And for the second equation, we'll put in the savings, which is 500 plus 1700 T. Of course, we have to press X on our calculator instead of T. And then we'll set the window. Now, here's the key thing I want to show you. We have to change these numbers so that it fits our picture. And we want to, it doesn't really make sense for X to be negative. So we'll start X at 0. And I'm going to go up to 6. Okay, and it's going to scale up by ones, meaning put a tick mark every 1 unit. And for the y's, we'll also start at the 0 because we're talking about money here. And I'm going to go up pretty high because think about what the car originally cost, over 18,000. So I'll just go up to 20,000, which should cover it. And I'll put a tick mark every 1,000 because I certainly don't want 2,000 or 20,000 tick marks. So, and then if we hit graph, it'll give us a nice picture. So it's really important to be able to know how to set that window up to get a good viewing picture. And again, that's right here on this window key is where you can do that. And then once you have that, you do second trace and then the intersect command that we've seen before, and then you hit enter on the first curve and enter for the second curve. And then for the guess, just move the cursor close and hit enter again. And these are the solutions right here. Now X is really the T for us. So you see that rounds off to 4.507, which is what we had. And the Y is the amount of money. Now it's the amount of money that the car will cost at that point, and it's also the amount of money the student will have saved at that point. And you see that rounds off to 8,162, which is the exact answer that we got before. So we can check this on our graphing calculator in that way. Okay, we're going to look at one more application, and this one's a little different from the last one because we're going to have to find the equation of the line that connects two different points in each case here. Now again, there's a lot of information here, so we want to kind of take it piece by piece. The problem deals with personal income in New Mexico versus Ohio. Now we know that the problem says that both of them are changing approximately linearly, so we can assume it's a straight line. And for New Mexico, it went from 23,941 in 2003 to 31,474 in 2007. In Ohio, it changed from 29,405 in 2003 to 34,874 in 2007. And we are asked to predict when the personal income of New Mexico and Ohio will be equal, and what will the income be at that point. Now we're going to let T represent the number of years after 2000. And just like before, we're going to have to create two different equations so that we have a system of equations. But this time we're going to do it a little bit differently. We're going to let Y represent the personal income. Now the key thing to realize is that we're given two different ordered pairs for New Mexico and also for Ohio. Let's start with New Mexico. Now in New Mexico, we know that in 2003, which would be a time value of 3, because that's 3 years after 2000, so 3, the personal income was $23,941. So we'll treat that as an ordered pair. And then we're also given that in 2007, now that would be t equals 7, that it was $31,474. So we have two different ordered pairs that correspond to New Mexico. Now the same is true for Ohio. It tells us that in 2003, so that would be t equal to 3, the income was $29,405. And in 2007, so t equals 7, it was $34,874. Now we know if we have two ordered pairs, which we do, I'm going to focus on New Mexico right now. If we have two ordered pairs, then we can find the equation of the line that goes through those 2 points. And the first step would be to calculate the slope. So, you do, y2 minus y1 over x2 minus x1. And work that out. And you can get it all the way down to a decimal in an application like this. So that comes out to be, if you plug that into your calculator, 1883.25. And then once you do that, you pick one of the two original points along with the slope, and you can use that point slope form. So we would have y minus 23,941 equals 1883.25 times the quantity t minus 3. Notice I'm using a t in place of the x because we decided to use t for time. And then once you distribute this out, which will be your next step, and then you'd have to add 23,941 to both sides to get the y alone. I'll let you do those steps, and you can check your answer with the one I'm getting. But if I skip that step, the answer comes out to be y equals 1883.25 t plus 18,291.25. So that would be the equation of the line. Now we could do the exact same thing for Ohio because we also have two different order pairs here. So we could find the slope and then go through the same exact process. I've actually done that, and to save a little time here, I'm just going to write down what the answer came out to be for that. So that came out to be y equals 1367.25 times t plus 25,303.25. And you could try that as an exercise and see if your answer matches the one I've got. But at this point, now we're back to, we have two different equations. Okay? It's a system of equations. So we have created a system of equations. And again, you use the substitution method since they're both solved for y. If you plug one in for the y in the other equation, it just amounts to setting the two equations equal to each other and then solving. So we would have, it's kind of long, but 1883.25 t plus 18,291.25 equals 1367.25t plus 25,303.25. And our job now is to solve for time, or t. So we want to collect our variables on the one side. I'll go ahead and get them over to the left side of the equation and get the numbers on the other side. And so when we do that, it ends up giving us 516t equals 7012, and then divide both sides by 516, and t comes out to be 13.608 years. And again, that would be years after 2000. And so that answers that part of the question. Now, the question also asked, what will the personal income be at that point? And so we would have to now substitute that back into one of our two equations. And when we do that, y comes out to be, and you can check this, you can plug it into either one of the two equations that we generated, and y comes out to be 43,909 if you round it slightly. That'd be the solution to your system.